Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 17, distance on the coordinate plane. Okay, so classwork example 1. What is the distance between the 2 points A and B on this coordinate plane? Well, A's value on this point is -3, 2. And B is at the point 3, 2. So my y values are the same. When two y values are the same, it's a horizontal line. So all I need to do is count from left to right how far A is from B. Well, how far is negative? How many point distance? How many units is 3 from -3? So you just go 1, 2, 3, 4, 5, 6. So the distance from A to B is 6 units. Okay, very simple. All I had to do was count. Now when I go to this one, what is the distance between the 2 points A and B on this coordinate plane? Well, A's coordinate is 2, 2, and B's coordinate is 2, 4. So in this case, my x's are the same, and when your x's are the same, it's a vertical line, and all I have to do is count from one y to the other y. So how many units is 2 from 4? Well, I just go 1, 2, or 4 minus 2 is 2 units. Okay. Now, on this one, it says, what is the distance between the 2 points A and B on the coordinate plane? Round your answer to the 10th place. Well, B is at the point 2, 4. And A is at the point 8, 2. X's are different, Y's are different, and when that happens, we have not a straight line, but a line that has slope. So we have this segment here. This is the line segment we're looking for. Okay, so how long is that? Well, actually I didn't want to delete that. Actually, I don't need it. Never mind. I can do this. So what we need to do to answer this question is find out how far we are from our y's, the distance of our two y's, and the distance of our y's, so it's y2 minus y1, okay? And that would be 4 minus 2. Why am I doing this as a fraction? I don't know. Actually, I was thinking of the y2 minus y1 over x2 minus x1, which is our slope m. And it kind of goes in line with that. So y2 minus y1, that is an absolute value distance of 2. And the distance of, so I don't want to do slope here because then I'd get a negative value. And I'm not looking for slope at this point. I'm looking for the length of AB, but it's along the lines of, get it, of the slope, taking the two portions. So from A to B, the distance in the y's was 2. Okay, I'm probably making this more complicated, but you just take the two y's and subtract, and that's 2. And then you take the two x's and subtract and get 6. So in other words, I would have a line segment that goes from here to here of length 6. Okay. And why I just did that is because I have created a right triangle. So in order to find this distance, I can't say that that's a distance of 1, and that's a distance of 2, and that's a distance 3, 4, 5, 6, because if I rotate this, AB is longer than 6. Okay, so let me show you that. If I take this and rotate it so it's flat, and move it down so that one end is on A, notice how much it sticks out past B, or this end here. So the green line is longer than the blue. It is more than 6. Okay, so I'll put that back. So I now know that AB is longer than 6. I can't count diagonally and say it's the same as a horizontal distance. So what we do is the Pythagorean theorem. Okay, so whenever we're solving a problem, remember, you write the formula. A squared plus B squared equals C squared. Now remember, your C is your hypotenuse or your longest side. That'll be our green one. So C squared is the green. A squared is 2, so that's going to be 2 squared plus B squared, which is 6. And that is going to equal C squared. So 2 squared is 4 plus 6 squared, and that's going to equal our green side, which is still C squared. I don't know that. So 4 plus 36 is 40, and 40 equals C squared. And then in order to solve that, I have to take the square root of both sides. So I have the square root of 40 is equal to C squared square root. In other words, the square root of 40 equals C. It says round your answer to the nearest tenth. Okay, if this weren't in the way. Round your answer to the nearest tenth place. So I know 40 is a little more than 36, and the square root of 36 is 6, so it's 6 point something. Let's use our calculator to calculate that. Okay, so here's my calculator, and I take the square root of 40 and hit enter, and it says round to the nearest tenth, so I have to go out to the 100th place and see if it's 5 or more to round up, and if it's not, leave this alone. So it's 6 approximately, so C is approximately 6.3 units. Okay, and as I rotated that, it was a little bit more than 6, so it's 6.3, and it came out to about here. Okay, so there you have it. Example 2. Given 2 points A and B on the coordinate plane, determine the distance. First make an estimate, then try to find more precise answer. So I'm going to get my ruler again, which is right here, and I'm going to draw a segment. Let's stick with the same colors. We'll make our hypotenuse green. So first it said to estimate. Well, if this is 1, 2, 3, and this is 1, 2, 3, I would say it's a little bit more than 3. So my estimate, I'm going to say, is 3.2. Okay, there's my estimate. But now we are going to do what we just previously had done, and I'm going to create a right triangle by finding the distance horizontally and the distance vertically, and form a right triangle. So the distance of A to here is 3. The distance from here to here is 3, and this is my C. So it's A squared plus B squared equals C squared. Write a formula, substitute the givens, simplify, okay, and 4 times 4 is 16. So the square root of 18 is 4.2 rounded. So C is approximately 4.2. Okay, so my estimate was 3.2. I was off by quite a bit. So I'm going to do this and show this. I'm going to take this. I'm going to rotate it until it's horizontal. Right about there. move it down here, and as you see, it is more than 4. So my estimate was off. Okay, so that is why we calculate exactly. So approximation 3.2, actual 4.2. I was off by 1 whole unit. Okay, now it's exercises 1 through 4. It says for each of the exercises, determine the distance between points A and B, round your answer to the 10th place. So now it's your turn to try this process. Pause the video, see how you do, and then come back. Okay, so here goes. I'm going to draw the segment we're trying to find the length of. I'm going to draw a segment going this way, a vertical segment on x equals 4, and that's going to create a right triangle. This is a distance of 1, 2, 3, 4, 5. This is a distance of 1, 2, 3, 4, 5, 6. And this is my C. So I'm going to write a squared plus b squared equals c squared. 5 squared plus 6 squared equals c squared. 25 plus 36 equals c squared. 61 equals c squared, therefore the square root of 61 equals the square root of c squared, so therefore the square root of 61 equals c. Square root 61, enter, is 7.8. So c is approximately 7.8 units. Okay. Now I'm just going to do this one more time. I just want to show you that if I take that segment, rotate it so it's horizontal. It's hard to do with my pen. Let me get my mouse. There's horizontal. And then move it down here to point A, or anywhere on the horizontal starting at an integer. Then it's, so if I did move it over to 0, 0 on the x-axis even, then I could count how long it is. There's 6, and then 7.8 is almost 8. So if I put that at 6, or -2, and that looks like 5.8 right there. So sure enough, it is 7.8 units long, approximately. Okay, number 2. Okay, we're just going to repeat this process. Draw a segment from A to B. Horizontally, vertically, formed a right angle here. This is 1, 2, 3, 4. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 5 is 13. And this is my C. So it's going to be A squared plus B squared equals C squared. 4 squared plus 13 squared equals C squared. 16 plus 169 equals C squared. 169 and 16 is 185 equals C squared. Take the square root of 185, take the square root of C squared, and I get the square root of 185 equals C. So C is approximately 13.6 units. Okay. Okay, here's number 3. So again, I'm going to get my ruler. Draw a nice straight line from A to B. This time I'm going to go above. It doesn't matter if you draw your right triangle above or below the line. The hypotenuse can be down below, or the two legs can be above the hypotenuse, or they can be below. It doesn't matter. I could have drawn it over here. We're going to get the same because it's a rectangle cut in half. Each piece is going to be equivalent. Okay, so we have 1, 2, 3 on this side, and 1, 2, 3, 4, 5 on this side, and we're going to let AB, length of AB equals C. So A squared plus B squared equals C squared. A is 3 plus B is 5 squared equals C squared. 9 plus 25 equals C squared. 34 equals C squared. Take the square root of 34, and that is equal to the square root of C squared, and therefore C equals the square root of 34. And I know that's close to 36, so the answer is going to be close to 6, so I'm going to say C is 5 point something. Get my calculator. The square root of 34 is 5.8. Approximately. Now, I've been writing equals, 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 and really I should be writing approximates because we are rounding. C is not equal to 5.8. C is approximately 5.8. And same goes with numbers 1 and 2. Okay, so now I'm going to move on and do number 4. Put my ruler's 0 at A. Rotate, draw the segment, rotate, draw my first leg A, rotate, draw leg B. That formed a right angle and therefore a right triangle. This is length 1, 2, 3, 4. And this is length 1, 2, 3, 4, 5. Okay, so I take, and this is my C. So we're going to let the length of AB equal C again. So we're going to write A squared plus B squared equals C squared. Substitute 4 squared plus 5 squared equals C squared. Simplify 16 plus 25 equals C squared. Simplify more. 41 equals C squared. And take the square root of both sides to get rid of that C squared. And I get the square root of 41 is equivalent to C. Okay. That's between 36 and 49. It's close to both, so I'm going to say it's probably 6 point something. And I'd say around 6.5 as an estimate because it's halfway in between. But let's take a look. The square root of 41. 6.4. Okay, so there it is. And I wrote equals again. I don't want to write equals. I want to write C is approximately 6.4 units. Okay, example 3. Is the triangle formed by the points A, B, and C a right triangle? Okay, in this situation, they're giving us 3 points, but now if I draw line segments here, watch what's going to happen. If I connect A and B, yeah, that is red. Everybody sees that, right? that is A and B. And then I'm going to rotate up, draw a segment from A to C, different color. And then I'm going to draw a segment from C to B. So I'm creating a triangle from these 3 points. And there we have it. Now, the problem with this is we only know one length. And it's from 1 to 11, so this is a distance of 10. I don't know the length of this green segment because it's at an angle. I don't know the length of this blue segment because it's at an angle. So what I need to do in this situation is make a right triangle of each and find the hypotenuse. So I'm going to draw a segment vertical, and I'm going to draw a segment horizontal on this green triangle. Now do you see a right triangle right here? And I know this is a distance of 1, and this is a distance of 3. So I can find the length of the green one. So I'm going to write a squared plus b squared equals c squared. Well, a is 1, b is 3, and c is c squared. 1 squared is 1, 3 squared is 9, equals c squared. So 10 equals c squared. Therefore, the square root of 10 equals the square root of c squared, and the square root of 10 equals c. I'm going to leave this in radical form. And now I'm going to do the same with the blue triangle. I need to find the length of the, or not the blue triangle, but the blue segment. So if I draw a horizontal line over here, rotate this, and bring this over here, I have now formed another right triangle with the right angle right here. So this is a length of 3, and I went from 2 to 11, which is a distance of 9. So I'm going to do a right triangle, or I'm going to do the Pythagorean theorem again, and I'm going to find the blue. So I'll do this equation in blue. So it's going to be a squared plus b squared equals c squared. A is 3 squared plus 9 squared equals c squared. So 9 plus 81 equals c squared, and that's 90 equals c squared. So the square root of 90 equals the square root of c squared, and therefore c, I guess I should leave it on the same, I can't flip it around, it doesn't matter, but the square root of 90 equals c. Now I'm going to leave this in radical form, and you'll see why in a moment. So what have I just done? Well, I now know that if I get rid of, let's just delete this stuff. If I get rid of that now and get rid of that, you don't have to erase it on your paper. I'm just doing this so it clarifies things. I'm just getting all this stuff out of the way. What have I just done? Well, when I made this right triangle over here, I found this length to be the square root of 10. And I found this length to be the square root of 90. And what I'm trying to answer in this question is this triangle a right triangle? That's the question. Is C a right triangle, a right angle? I can do better than that. There's my possible right angle, question mark. Is that a right angle? That's the question. Well, now I have to do the Pythagorean theorem one last time to check. This is the converse of the Pythagorean theorem, which we did in our last lesson. So we take a squared plus b squared equals c squared. We do know that's true. In this right triangle, keep in mind that a and b don't matter what we name. This could be a, this could be b, this could be a, this could be b. But this absolutely positively has to be opposite the angle that we think is the 90-degree angle if it is going to be a hypotenuse. So I know C is going to be 10 squared. So A, it doesn't matter. So it's going to be the square root of 10, I'll make A, plus the square root of 90, I will make B. And here's why I decided to just leave them in radical form. When you square a square root, the square root and the square go away, and the radicand, the number in the radical, is our answer. Because the square root of 100, or square root of 10, times the square root of 10 is 100. And the square root of 100 is 10. In other words, these cancel, and we simply get 10. The square root of 90 times the square root of 90 is the square root of 8,100. And the square root of 8,100 is 90. In other words, the radical and the squares cancel, and I just get 90. And 10 squared is 100. And then 10 plus 90 is 100. 100 equals 100. That is a true statement. Therefore, triangle A, B, C is a right triangle. Okay, that is the end of lesson 17. Review the lesson summary and go to your problem set.